So we're going to talk about module 2 and compute in the cloud. These are our objectives really for this next little bit, is that we're going to talk about the benefits of Amazon EC2. We're going to talk about EC2 instance types. We're going to talk about the different like billing options or licensing options that you have when you want to run virtual machines inside of AWS. And then we're going to talk about some adjunctive services that enhance your virtual machine experience, like can make virtual machines actually be cheaper on AWS than they are in your data center by far. And then we're going to talk about SNS and SQS, which are kind of, if you will, like buffers or duplicators that can be used to kind of like make an application communicate a little differently. I think would be the best way to say it. And then we'll summarize some additional compute options such as containers and serverless, which are the two other ways in which you can actually host applications. Before we do that, we are going to take a short break. So currently it's 9:18. And so why don't you all come back at 9:30, grab water, coffee, leave your seat, whatever you need to do. But we're going to come back at 9:30 and then we're going to resume the class. Okay. So we'll see everybody in just a bit. Yeah, a little trumpet sound. Okay. So this is all going to be about virtual machines. Pretty straightforward. Okay. So we're back to our client server model. We're going to ask for a virtual machine. We're going to ask for a virtual machine with a certain operating system of a certain size, and we're going to ask for it to be in a certain location. And we're going to answer some questions about the firewalls and other stuff that are around it. And that's what we're going to do. So it's no different than going in to order a cup of coffee. The only difference is this is all done electronically, either through clicks on a website or through command line submission or through the submission of code, right? So the EC2, the Elastic Compute Cloud, is Amazon's virtual machine service. And I don't want to, genericize it and say like all virtual machine services are the same, because they're not, right? Virtual machines on Azure are slightly different than virtual machines on AWS versus Google versus Linode versus Vultr versus DigitalOcean. They're different, right? Now, that doesn't mean, though, that they don't all have common components. And so hopefully those concepts, if you're used to using a laptop, you can apply those here. Here's how. One, when you choose a laptop, you want it to have a certain operating system on it. Now, here's the cool thing. If it's a MacBook, it probably already has a Mac OS on it. If it's, an Intel-based laptop, it typically already has Windows on it, right? It won't have Linux on it, although you can order Linux laptops, so don't get that wrong. But those are the three flavors of operating systems, is that you basically are going to launch an instance. So in this case, an instance, by the way, is the same word as a virtual machine. So if someone says an EC2 instance, they're talking about a virtual machine. From there, you can connect to the instance, because remember, this virtual machine is running on somebody else's infrastructure. If it was on your desktop, you would just see it come up on your monitors. But instead, you have to use something else to connect to that virtual machine. Now, you can connect to a virtual machine through SSH, which is like command line terminal stuff, or you can use RDP, which will give you a window. You could use, and you can't do this with AWS. I don't, at least I've never tried it. I don't think you can. You're not going to use like VNC or some other open source utility. It's either going to be SSH or RDP. Those are really your two options. Now, that all being said, once you connect to the instance, you can use it and then execute the way you want and then give it back when you're done. And it's really just that simple. Now, you might say, well, Michael, what if I want a really big box? What if I'm like, I really want a system that has 448 processors and 24 terabytes of memory? I know. They have that, by the way. And it is worth saying also that Amazon will give you access to the hypervisor on a physical box. So while we're mainly focused on virtual machines, Amazon will actually give you access to a physical box inside their data center through a console. Other things to note is that people specialize in different areas. For example, we could have a barista who specializes in coffee, someone who specializes being a cashier, and someone who specializes in inventory. Amazon does the same thing when they think about their virtual machines. What if you only wanted a general purpose virtual machine? One that didn't have a whole lot of CPUs, not a whole lot of memory, not a whole lot of like disk performance, and they didn't want to add any GPUs in it. What if they just wanted to give you a general purpose box? These boxes typically have a 4-to-1 ratio of memory to processor. So you get 4 gigs of memory, right? You get 1 processor. You get 8 gigs of memory, you get 2 processors. That's pretty standard. And they also have compute optimized systems, and these boxes specialize in having access to a really high performance processor, and they're usually 2-to-1. So 2 gigs of memory for every processor, right? Why? Because they're processor intensive, not memory intensive. Now, these boxes, by the way, typically start with the letter C. C6s, C5s, right? And they'll have other letters behind them, but generally that's how they approach it. They'll start with C's. Now, general purpose boxes will typically start with M or T. M for median, T for test. Those are my mnemonics, by the way. And then in addition to general purpose boxes like virtual machines, compute optimized virtual machines, they also have what they call memory optimized virtual machines. These start with R for RAM. And these boxes are used specifically when you need a high memory footprint compared to processor. So this is 8-to-1. So if you have 8 processors, multiply that times 8, you're going to end up with 64 gigs of RAM. So you've got compute optimized, you've got memory optimized. Does anyone want to guess, by the way, if I've talked about systems that are optimized for compute, systems that are optimized for memory, someone take a wild guess for me and tell me what the next one of these like design types is going to be. What are one of the subsystems of a computer that I haven't talked about yet, other than CPU and memory? What's another one? Storage. Thanks, Brian. So storage optimized is also one of the types. So disk optimized. So that means that Amazon has virtual machines that come with incredibly fast disks. How fast? 256,000 IO per second. 120,000, 185,000 IO per second, 64,000 IO per second. Like they come with these boxes. Some of these boxes are disks. They're just like lightning fast. I know I was geeking out a little bit. One thing worth mentioning though is that in addition to CPU optimized systems, memory optimized systems, disk optimized systems, they also have GPU optimized systems, which is what accelerated computing is. So if your data scientists and your machine learning people come back to you and say, hey, I need a GPU on my virtual machine so I can do hashes and like machine learning models faster. They're asking for an accelerated computing box. And you might say, well, hold on, Michael, I thought only gamers use GPUs. Well, don't get me wrong, they're great for 3D rendering as well if you want that. But most GPUs are now used either for altcoin, which is unfortunate. I mean, don't get me wrong, I like altcoin, but most of these are actually used for machine learning, right? So machine learning and altcoin are pretty much where GPUs are landing nowadays. If you are a do-it-yourself kind of build your own PC person, you're kind of like, man, can't really buy a video card. Why is that? Well, it's not because of Bitcoin, just so we're clear. Bitcoin uses specialized cards called ASICs to do its mining. It's because of altcoins like Ethereum and other stuff. So Solana, Cardano, that kind of thing. Point being is that you can get systems designed for your use case. But I just want to be upfront about it. Unless someone comes to you and says, Michael, we're running a database and we need 185,000 IOPS per second. I mean, most vendor documentation doesn't say that. What they say is that you need a box with at least 4 processors and 16 gigs of RAM. Here's how you figure that out, by the way. I'm going to share a website with you called EC2instances.info. I'm going to paste that in the chat. Oops, hold on. Sorry, my mistake. There we go. EC2instances.info. EC2instances.info is going to take you to a website that looks like this. It's going to redirect you, by the way, to instances.vantage.sh. That's because a company bought this open source project here recently. So when you're here, let's say a vendor has come to you and said, Michael, I need 16 processors. So notice I'm going to click up here into virtual CPUs. And when I click up here, I'm actually going to choose 16. And then they're going to say, I need at least 64 gigs of memory. What just happened? Well, instantly what happened is they showed me all the systems where there were 16 virtual CPUs and 16 gigs of memory. By the way, that is a 4-to-1 ratio, right? So I automatically know that's going to be general purpose because that meets the 4-to-1 ratio. And so notice there's the M series. There are some new graphics machines here, right? But again, unless I needed like graphics cards, I probably wouldn't use these. M6s, M5s, and you might say, but Michael, hold on. What's the difference between a 4X large and an M5A and an M6A? What do those letters mean? So once you identify the machines that you could use, the other thing that you have to do is you have to type in AWS EC2 instance types, and you actually have to go look at the documentation. You're not going to get tested on this. You need to know that there are 5 different like families or categories of machines, but you don't need to memorize every number or every like suffix, right? You don't need to memorize that there's a T4G and a T3, but you need to know that the T series is used for general purpose. The C series, as I mentioned before, and by the way, they just released the HPCs yesterday, but the C series is compute optimized. R, along with X's, right, and a couple others are memory optimized. Accelerated computings are your P's and your G's. Storage optimized is either I's or D's in general, right? So you don't need to memorize what all those are. You just need to go look them up. For example, we were just looking at M6As, right? Where are M6As? Let's click on these. These are AMD processors. The M5A is also an AMD processor. Let's go look at the M6I. This is an Intel Xeon Scalable processor. What's the G? G stands for Gravitron, which is an ARM-based processor that Amazon came up with. They developed it. It uses like the ARM Neoverse cores, right? So be aware that you don't need to memorize any of this. You're going to look it up just like any sane person, because this is going to change all the time. But if you need to look for a certain size of machine, find it here first and then go look it up in the documentation to make sure it meets your needs. By the way, you can also just loosely compare pricing. If all you need is a 64, 16 gig machine with nothing special, go over here and look for the one with the cheapest price and then pick them out. And then, like, for example, this is an AMD box, so that'll work fine. But this box down here is a Gravitron box, which means your stuff all needs to be compiled for ARM. That's not going to work for most people, right? So you got to do a little bit of research beyond that. General thought, though, remember that there are general purpose boxes, compute boxes, memory boxes, storage boxes, and then there's GPU boxes, which are called accelerated computing boxes, okay? Just a word of caution, because I'm going to talk about this topic later, is that some of these boxes come with quote unquote free storage. It's called instant storage. You can actually see it up here. See the instant storage on here? Some of these virtual machines come with free storage. Do not use that storage in production. You know what I have to say about Michael? Hold on. That's an NVMe drive. That's an SSD drive. That thing is probably super fast. It is super fast, but if the box crashes, you're going to lose every single piece of data on that hard drive. Like just to be clear, instant storage is available for like scratch drives and temporary usage. But if that system stops or that host crashes, you're going to lose all the data on that drive, which is not what happens when you use EBS, which is the virtual hard drive service that goes with your virtual machines. So don't be fooled. There's free storage that come with these virtual machines. Don't use it unless you really know what you're doing, which you might. All right, 5 classes of boxes, right? Just remember that. Now, based on what I just said, little check here. If I need a box that has enough memory for me to put all of my data sets into memory so I don't have to touch the disk or use compute, which of these generally designed groups of boxes am I going to use for a high performance database that needs a lot of memory? No, no guesses? Well, if I had a high performance database that was like loading a bunch of stuff into memory, then I would probably actually go for memory optimized. Why? Because I don't want it to touch the disk, right? That's what I would choose. All right, which of these do you think was suitable for data warehousing applications that either needed fast disk or large amounts of storage where they could store things? Which of the systems on the right-hand side would be ideal for that? Good. Yeah, Gabriella and Darren, that would be D, right? D would be where I'm like, hey, I need storage optimized systems. Good. All right, and then which one would be perfect if I needed a balanced approach to networking, compute, storage, and memory? What would be the best one for that? Good. And then the last one, of course, is easy because it's the only one left, right? Offers high performance processors. Well, that's going to be compute optimized. Good. Any questions about any of the things that we just talked about? All right, here's a question for you. What is the name of the family type that isn't listed here that governs GPUs? What does Amazon call that class of virtual machines? That's right. They call it is GPU, but there's a special name for it. Brian, there we go. Accelerated. Good. Yeah, accelerated computing. That's what they call their GPU options. Okay. Now, you may have noticed that when we were looking over here before, I'm going to shrink this down a little bit, that there was the on-demand cost listed over here. And then there was the reserve cost and there was the spot cost. And that's like, what? What does that mean? And as we scroll over, by the way, there's also Windows versions of those. So Windows on demand, Windows reserved, although I didn't see a Windows spot cost, but there is. You can get Windows spot. Okay, why is this significant? So on demand is the retail cost for this virtual machine. So let's pick another one. So let me clear this out really quick. And let's choose my favorite boxes for testing, which are known as T3s. So let's do T3s for a second, okay? So here, notice that we've got t-shirt sizes here. So if I sort it by memory, notice it goes from nano to micro to small to medium to large to extra large. And let me blow that up because that one you can at least see in larger scale. So nano, micro, small, medium, large, extra large, 2x large. Notice that there's t-shirt sizes associated with these family types. So this is the T series, which is the general purpose testing series. Again, testing is my mnemonic, not AWS's. They actually refer to these as just general purpose, but they're not. They have caveats. Notice that this is a 32 by 8 system. So that's 8 processors multiplied times 4. That gives you 32 gigs of memory. Notice that continues until you get down to the past the mediums, to the smalls, the micros, and the nanos. And then memory goes down precipitously while virtual CPUs stays pretty consistent. But the thing I want you to note is that if we go to the cheapest box, it's 0.0052 cents per hour. By the way, this is billed per second. They're just giving you the hourly cost, right? So this is billed per second. So divide that by 3,600, and that'll give you the per second cost, right? Now, the thing that's significant about this is that notice that the on-demand cost, and let's go up to the micro box. This is basically 0.0104 cents an hour. If I actually go over and get into a relationship with Amazon for either 1 or 3 years where I commit to pay for that box, even if I'm not using it, that's a catch, right? Then what will happen is they're going to give me up to a 40% discount in general. That discount, by the way, can go up to 70% if I commit to 3 years over a year. So this reserved cost is where you actually get into a loose, very loose contract with AWS. And you say, hey, Amazon, I'm going to run this workload for over a year. So I want you to, and it's going to be Linux, and I'm going to run it in Virginia, and it's going to be a T3 micro, and I'm going to run it in your first data center in Virginia. In exchange, I want you to give me a 40% discount. And Amazon's like, yep, we're done. So you agree to the term that you want and the like all the flavors, like what operating system is it, et cetera, et cetera. And Amazon will in turn tell you the percentage of discount they'll give you. It usually ranges from somewhere between 30 to 70% discounts. And that's what they call a reservation or a reserved instance. You are committing for either 1 or 3 years to pay for that instance 24/7. And so that's different from on demand. On demand is that you spend the box up, you use it for 30 seconds, and then you spin it down. On demand, you're not making any commitments, but you have to pay full retail price for that box. That's what on demand is. Now, that's a big contrast, say, from something like spot instances, which is over here on the right-hand side. Notice that if I pay 0.01 cents over here and I pay 0.00 cents over here, notice that the cost goes way down on spot instances. Now, here's the catch. Imagine that you're Amazon and you have provisioned your data center to be able to host 100 T3 micros, which is the size of box that I'm hovering over right now. So you built up enough hardware to host 100 T3 micros in one of your data centers. And let's say that for whatever reason, people are not using T3 micros, but you bought all this hardware for it, and no one is paying either on demand or reserved costs for your T3 micros, meaning no one's using them. And you're scratching your head going, man, we spent tons of money on this hardware and nobody's using it. How about we do this? Someone came up with a great idea and said, you know what? Let's offer people our unused capacity because no one's paying on demand and no one's paying reserve pricing for these systems. Let's drop the price by up to 90%. And if people want to use it, they can. But if someone starts an on-demand box or if someone starts a reserve box, we'll give the spot people a 2-minute warning and we'll take the box away from them and give it to the people who are willing to pay more. I mean, I got to tell you, it's a genius model, right? Because you can either pay either on demand or reserve cost if you want for certain to have a box. But if you're like, I can withstand interruption, you can say, you know what, I'm going to bid on some spot boxes, let them run. And when Amazon needs to take them, I'll write all my data out within 2 minutes and then I'll give, they'll take the box back, right? So it's a great model, particularly if your application can withstand interruption. So let's say you're working on a reporting application. It takes 20 hours to run, and it usually costs you $2,000 to work it. But you don't need it until the first of the month, and it's the second of the previous month. You could actually run that application in a spot instance, have it write out data every 2 minutes. If the box gets taken away, it just checks to see where it was at, and then it finishes the report. And instead of spending $2,000, you spent minus 90%, which means you spent $200, right? Okay, is that right? Yeah, let's just go with that, right? In other words, you spent minus 90% on that. So you might think to yourself, but Michael, like 2 minutes, that's crazy. Like, what if I can't support that? Well, your application has to support interruptions in order for you to use Spot. You can't use Spot unless your application is stateless or it can write its state out to a third party. Okay. So, but that's that's the third of the licensing models is you've got on demand, you've got reserved, which are also called reservations, and then you've got spot instances. So if we go back to our slides, on demand is the most expensive way. Well, actually, let me caveat that it is the second most expensive way because you can actually ask for dedicated hosts. That's the most expensive, but it is one of the most expensive ways to use AWS. But here's the cool thing. It's a little bit like dating somebody, right? you want to make commitments and communicate and all that stuff and, be upfront about it. But like, you're like, it's not really working out because you like dogs and I like cats. And that's a big deal to me. It's non-negotiable. And we're just going to stop dating. And the point being is that that's kind of the thing that you're in with Amazon, is that you're in relationship with them, you're dating, but you're not committed in that space. So if you have a fear of commitment, this might be a good model for you. I kind of joke, but that could be a serious discussion. Then spot instances is the model that I was just talking about, where Amazon's got a bunch of extra capacity and they're willing to give you that extra capacity at whatever price you're willing to pay for it, but you never pay more than on-demand price. Isn't that cool? So if the instance costs you $1 an hour, if you use spot instances, you could save up to 90 cents off that $1 an hour, but you're never going to pay more than $1 an hour. But remember, spot instances can only work if the workload has a flexible start and end time, right? Remember that. And then reserved instances and compute savings plans are kind of two different coins of the same thing. This is where you're going to get married to Amazon. I mean, that sounds weird, actually. In terms of like that whole analogy of like dating, right? This is where you're going to say, you know what, we're going to get married for a year or 3 years, which might be an interesting model. I don't think that would work for me, but whatever. Regardless, let's say you're reserved or your compute savings plan, and you're like, hey, we're going to get into a committed relationship for a year or 3 years. And in exchange, you're going to realize some amazing benefits. So with reserved, you can actually save up to, I think, 72% or 74% of savings, depending on what kind of commitment that you make. With a compute savings plan, it's a little different because you give Amazon money, like give them $10,000 now, and they'll give you an extra amount of value. In other words, you give them $10,000 now and they'll give you $16,000 worth of value. And what will happen is it still requires a 1 year or 3 year commitment, but you give them that money and they in turn will make that dollar way more valuable in the AWS ecosystem. Compute savings plans, by the way, can be applied to not just EC2. They can also be applied to Lambda and containers, and also to machine learning. So if you're using SageMaker a lot, you can apply it there. Remember, though, that these require commitments. So you will have to commit to either a year or a 3 year term for this. You can't actually sell your reservations in the marketplace. Also know that, if, for example, with the compute savings plans, if you give them $10,000 and you don't use it within a year, it expires and that money disappears. So you do have to understand the fine details, but just know it is totally worth it. May not sound like it, but it is actually worth it. Now, the most expensive way to use AWS, I referred to this before, is you tell Amazon that you do not want to share their hardware with other customers, and you want what's called dedicated tenancy. Dedicated tenancy means that you're not willing to play with other kids on the playground. You want the playground all to yourself, which there's nothing wrong with that. That's the way you want it. You have security or licensing requirements that require you to have your own dedicated hardware. And so that's when you get a dedicated host or dedicated instance. So just know, this is when you're like, nope, the DoD will not allow me to have this application co-live with anybody else. Now, I say that, let's take this in for a second. And this is not meant to be derogatory. Other cloud providers have had major security breaches. AWS hasn't, which doesn't mean they're not going to, right? I'm sure at some point in time they will. But one thing that's really cool about how AWS, because they're primarily first and foremost a security company, you can't see other people's network traffic. You can't see their DNS calls. You can't see their Windows activations. AWS takes security extremely serious. And let me be clear, not all cloud providers do, right? And I'm not poking fun at anybody, but they just don't. Amazon takes it extremely seriously. So just know that even though if you decide not to use a dedicated host, you can't see other people's traffic. You can't sniff it. And Amazon goes the extra mile to make sure that even if there's a 0-day vulnerability in their stuff, you still can't see it, right? Like a couple years back, there was a 0-day vulnerability in the Zen hypervisor they were using, but it didn't apply to them, even though they did actually have to patch the systems. But it didn't apply to them because they already had mitigations in place, because they were doing defense in depth. They were doing separation of concerns. they were doing all the things that you should be doing in order to build trust with customers. And so the other thing to say about this is that while I'm not necessarily an AWS fanboy, one thing that does happen is that if there's ever any kind of breach with them, which minor things have happened, that have gotten them, visibility in the news, they then double down on security, raise it as visible as possible, so everybody knows that this is never going to happen this particular way again. So just know that even if you're not using dedicated hosts, you're not vulnerable, right? And let me be clear about that. Obviously, every infrastructure has risks and vulnerabilities, but Amazon does go the extra mile to make that happen. Remember, this is the most expensive way to use Amazon. This is the second most expensive. This is the third. This is the fourth. And spot instances are the cheapest way to use AWS. But all of them come with their own caveats. Okay? Question before we move into some knowledge checks. Okay. So what's the difference between a compute savings plan and spot instances? So I just, and notice it didn't say compute savings plans and reserved instances, it said spot instances. For example, let me ask you this. What are the time commitments that you need to make with compute savings plans? Is there a time commitment with compute savings plans? And if so, what is it? What's the time commitment? Good. 1 to 3 years. Is there a time commitment for spot instances? In other words, do you have to pay for spot instances? Do you have to make a commitment to use spot? Okay, well then what's the problem with spot? Spot is awesome because you can get a 90% discount, but what's going to happen with spot instances when a paying customer comes and asks for that same system? Yeah, interruptions. You got to be able to withstand interruptions. How much time is Amazon going to give you before they take that instance away from you once they signal you that they need it? That's right. You got 2 minutes specifically. So your application, by the way, needs to watch for that signal. And the minute it sees that signal, it's got to write data out. But I just want to caution you, don't wait until you get a signal to start writing data out. You should be writing data out every time after you process and batch data. You should write it out to an external data store. That way, if all of a sudden you lose the instance, you might lose a minute's worth of processing time. So you should already be writing data out every 2 minutes anyway, right? Depending on how long it takes you for you to write that data to a data system. So compute savings plans, by the way, are also centered around money, which you then spend on compute. Spot instances are dependent upon size, meaning a T3 micro or a T3 small or a T3 medium or a T3 extra large, right? You actually have to choose the box that you want. Whereas compute savings plans don't really care so much about the size of the box that you use. You're actually eating out of a dollar that has been enhanced. Good. Any questions at all about the 5 categories of virtual machines, the 6 billing types for virtual machines, how you would size virtual machines? Oh, actually, here's a question for you. What are the 3 operating systems that you can run inside of AWS officially? Just give me one if you got it. I don't want specific flavors, by the way. I just want broad strokes. So don't tell me Gentoo or Debian. I'm not interested in that. The type of operating system. Perfect, Elena. That's excellent. Linux, Mac OS, and Windows, right? That governs all of them. Whether it's Ubuntu or Arch or Red Hat or whatever, no one cares. So like they don't run Unixes either. So don't ask me about Solaris or HPUX or even BSD. They don't run that. Now, don't get me wrong. People have put those out on AWS, but AWS only supports the big 3. So Linux, Mac, and Windows. Okay. Okay, let's talk about a service that provides a secret sauce enhancement to how you run virtual machines. And you're like, what, Michael, did you just say secret sauce? I know, I'm silly like that. auto scaling is one of the three pieces of what I consider to be a secret sauce that makes virtual machines on AWS spectacular, like seriously spectacular. Otherwise, it's just like it's like expensive data center 2.0, right? If you don't use the things that I'm about to talk about to run your virtual machines, you're not really running cloud optimized workloads at that point in time. I'm not judging you. I'm just saying, like, you want to think about it, right? All right. So here's what auto scaling does. Auto scaling's sole job is to add capacity when you need it. And I'm talking specifically about adding virtual machines or instances when you need them and take them away when you don't. So when demand gets high, in our coffee shop example, it adds makers of coffee so that people don't have to wait. Because in our age of convenience, people get really ticked off when they have to wait for stuff. Although sometimes I get joyful because then I can just slow down and just kind of enjoy the moment. Now, in the old world, back in my day, I had to walk up the hill in the snow both ways. Anyway, a joke, obviously. You had to buy hardware capacity that would match your maximum day. So imagine, by the way, you're Amazon.com, it's 2002, and you have to buy enough hardware so that you can support Christmas, but for the rest of the year, you're at 1/4 of your normal workload. But then Christmas comes back around and you got to buy 4 times the hardware. But then after January 15th, you're back to 1/4 of your workload. That's where Amazon used to be back in the early 2000s. Is like, they were like, this is crazy, right? Because people would they'd have to buy 4 times the amount of hardware that they would normally need for the rest of the year for 60 days. So what happens is that Amazon decided in 2001, someone wrote a paper, I think it was Vogel actually, who said, you know what if we just offered our extra capacity out to customers? Because we're not using it, but we still need it, right? And so this is where auto scaling, like part of the auto scaling concept came out. It's like, oh, well, why don't we make it so that people can elastically scale out their capacity as they need it based on a metric like latency or number of connections or customers or response time. And we're going to scale it down when it's 3 o'clock in the morning on a Saturday, so we're not wasting money. And so Amazon came up with this auto scaling concept, which, they weren't the first to come up with it, but they're the first ones to implement it in software so that we could use it, which then allowed customers to scale things up and scale things down as they needed. But this is what this service does. This service works with 2 other services, but its sole job is to either add or remove virtual machines from what they call an auto scaling group. And these virtual machines are all the same. So it's like one class of web servers or one class of application servers. So everything that's in the auto scaling group is identical. So they might add a bunch of web servers, remove a bunch of web servers. They might have another auto scaling group that has Tomcat servers. They add Tomcat servers, they take them away. You don't tend to do this, by the way, with databases, at least not RDBMSs. You could do it with something like Elasticsearch, but you'd have to be very careful. Okay, that was all auto scaling. Sole job is to add and remove virtual machines. Now, how do we direct traffic to all these virtual machines? If I've got 2 virtual machines, then all of a sudden I've got 50, Michael, how do I direct traffic to now 50 virtual machines when previously I had 2? How do my customers find these extra virtual machines? Am I going to stick that in DNS? No, don't do that. That's a bad idea, right? Instead, you're going to use what's called like a traffic redirector, which is going to like balance your workload. This traffic director is called an elastic load balancer in AWS. Its job is to act as a termination point to send all of your traffic to, and it in turn acts as a proxy and sends the traffic across all the boxes you have. So it's a single point of contact for your auto scaling group. Now this looks like a single point of failure, but I got to tell you, and just make sure that everyone takes this in, this is not a single point of failure. This is a virtual endpoint that has multiple devices underneath it. So don't think of this as a single point of failure. It looks like one device, it's actually like 50. And its job is that when you go to www.amazon.com, Amazon.com actually resolves to a load balancer, and that load balancer then distributes that request from you to one of its backend servers that is registered with the load balancer. So the job here is for the load balancer to abstract away the number of servers that are in the auto scaling group, which can go up and down, and to direct you to a system that can handle your requests. That's what a load balancer does. Is it during low demand, it directs it to a smaller set of servers. During high demand, it sends it to a higher set of servers, like a larger set of servers. And by the way, this is not something unique to AWS. They didn't invent load balancing. Load balancing has been around through F5 and other companies for a long time, but they are certainly the first ones to implement it at scale in cloud. Now, does that mean they're better? I think they're first, great. But just so you know, there's a couple of different flavors of elastic load balancing. There's application load balancing, there's network load balancing, there's what they call security or gateway load balancing. And there's also a classic load balancer, but don't use that one because it's being retired. So there's a bunch of different flavors for this, but load balancing works in conjunction with auto scaling. Let me define this one more time. The auto scaling service, its job is to add or remove instances. The load balancer's job is to distribute traffic evenly across whatever number of virtual machines are available. Okay, so two different purposes, but they work together. Now, that being said, is number one, removing unneeded Amazon EC2 instances when demand is low, is that the function of auto scaling, which you can shorthand to AS, or is it the function of an ELB, the elastic load balancer? Who's responsible for removing unneeded EC2 instances when the demand is low? That's right, auto scaling. Oh, never mind. I'm just going to give you the answer to the second one too. I apologize for hyperclicking. So if you want to add a second Amazon EC2 instance to an online store popular sale, that's also auto scaling. So basically anything related to adding or removing instances, that's going to be auto scaling. If you want to distribute a workload across several EC2 instances, what do you use for that? That's right. You're going to use the load balancer. To ensure that no single EC2 instance has to carry the full network workload on its own, what do you use for that? An AS or an ELB? Good, that's right. If you want to automatically adjust the number of EC2 instances to match demand, is that an AS or an ELB? Good. This last one's a little bit of a gimme because it contains the name of one of the two options. So that means that automatically it's excluded, right? Providing a single point of contact for traffic in an auto scaling group. I'm not going to insult your intelligence. You obviously know it's an ELB because just by elimination, right? Good. The third service that we didn't really talk about that kind of makes up this kind of like relationship to make virtual machines scale up and down is called CloudWatch. CloudWatch is going to show up under monitoring when we get to that module. I think it's module 9, if I remember correctly, maybe 7. But CloudWatch is used whenever you need metrics about a service like EC2 or a load balancer. So just know that in this case, you would actually use auto scaling with a load balancer with CloudWatch to track against metrics. For example, if you want to make sure that the entire system stays at no more than 80% average CPU utilization, plus or minus 10%, you can actually set that up with CloudWatch and then have it trigger an alarm, which talks to auto scaling, which then triggers instances, which then talk to a load balancer. So there's a relationship between elastic load balancing, CloudWatch, and auto scaling. Good. Any question before we talk about application messaging services? Okay. All right. So applications are made up of like multiple components. And what do those components do? It could be like credit card billing, recommendations, account management, order management, inventory management, notifications. In other words, an application has a couple of different components to it. One of these could be a database interface. It could be the user interface, like a web, like Netflix's like website, for example. If this all put together into a single code base where the concerns are all functioning out of the same code base is typically called a monolithic application. I don't know why they use the word monolithic. It means like one stone, I guess, versus separate stones. And this is actually a great place to start. And it's actually where most applications should start. But as we get bigger and we want to scale, especially if we want to scale the way like, LinkedIn and Google and Netflix and those guys scale, what needs to happen is that these components need to be separated out and they need to talk to each other through separate code bases, but they also need to talk to each other through standard APIs or application programming interfaces. So the reason we do this, by the way, is so that if component one is billing and all of a sudden everybody has to update their credit card because American Express had a breach and gave everybody new cards, which hadn't happened, but just throwing that out there. Do you really need to scale the entire application just because more users are in the billing console? No. Now, the cost of microservices is an increased amount of complexity because now you have more deployable discrete units. But the thing here is that we're trying to get it so that these systems can scale because we're not really afraid of complexity because we've got great tools to manage this. But what if you needed to create a buffer right here? Like you needed a buffer at this level so that component one could pass on a bunch of messages to component two and not completely crush component two. What if you needed to do that, right? Or even better, you wanted to add some kind of like caching mechanism here so that component one could go talk to component, like the messages that component one was putting down. So let's say component two, you didn't want to overwhelm component two. You could put a buffer in between them so that like this buffer could hold all the communications and then component two could go grab them as it had capacity to do so. That's really what we're going to talk about in this next section is that we're going to talk about two services. One is the simple notification service, which you are all familiar with the general concept. You know why? Because we all have email. And when you subscribe to a topic, like someone else's email address list, that's exactly how the simple notification service works. You subscribe to a topic and then messages are published to the topic and everybody who subscribed gets the message. So it takes one message and duplicates it however many times over it needs to so that every subscriber to the topic has a copy. Subscribers, by the way, will typically immediately receive their messages. There's typically not a delay. And that's how it commonly works. Now, you might say, Michael, that's an interesting approach. Like, why would we want to duplicate messages? Well, for the exact same reason, right? So for example, let's say we're running our coffee shop and we want to send out information about coupons, coffee trivia, new products. We could have separate topics that people could subscribe to that might let people know when we have new products or new coupons or whatever. By the way, this is useful programmatically for software applications because this allows us to take a single event and have that event trigger multiple responses. I'll give you an example. Let's say someone uploads a cat video to S3 and you run a cat video processing company. They upload that video to S3. S3 sends an SNS trigger to call 5 different resizing functions that then make the cat video available at a desktop resolution, at a mobile resolution, at a tablet resolution or phone resolution. So you can use this to actually duplicate a message and cause things to happen in parallel. So that's what SNS is used for, is for message duplication when you want to have something run in parallel. Now contrast that with the sister service, which is called the queuing service. And most of us are familiar with the queuing service if we've ever seen any movie where someone's working at a diner, or you've ever been to a coffee shop. Let's say you go to the coffee shop and someone orders something, you pay the cashier gives the order directly to the barista, and the barista starts making the drink. But what if the barista is already in the middle of making 5 other drinks? Well, we got to queue it up. We got to like queue up the orders and let the barista or baristas make those orders one at a time, because that's all they can do. They can't work on 5 things at once. They can work on one thing at once. So you got 3 baristas, but you got 12 orders. They can each work on about 3 orders at a time, give or take. So the simple queuing service and the simple notification service are 2 services that allow you to act as a buffer between your applications. Again, the queue acts just like any other queue, and the notification service acts kind of more like email. Any questions about SQS or SNS just at a high level as far as what they do? Okay. Just know that we will take a break after this. Wow. Okay, so here's some models of computing. So before I go into this, let me just say this, is that there's actually 3 ways to host code, to host an application. You can do it inside of a virtual machine. You can do it inside of a container, which has to sit inside of a virtual machine. And then you can do it inside what they call serverless, which just means that the virtual machine is hidden from you. AWS is managing it. And so all you're doing is giving them your code, and they're going to take care of it from there. You're never going to get to see or log into the virtual machine. This is serverless, which means this is the highest level of abstraction. This is basically where you give AWS your code. So you don't use virtual servers. You basically give AWS your code, and they take care of all the server management for you, right? So this is where you run code without provisioning or managing servers. You only pay for the compute time. So just to say this, if you run a virtual machine and you put an app on it, and that app is only used 2 hours a day, you're still paying 24/7 for that virtual machine. Remember, you pay for what you use. And if you're using an entire virtual machine to host one application that's only used 10% of the day, that's what's going to happen, right? Now, with Lambda, it's a little different because you upload your code to Lambda. You set some kind of event trigger, for example, uploading a cat video to an S3 bucket. That in turn will trigger the Lambda function, which then could do a resize of the cat video and then send a message out when it's done. You only pay for the compute time you use in that scenario. So if your Lambda function only runs for 30 seconds, you pay for 30 seconds. If it runs for 3 minutes, you pay for 3 minutes. If it runs for 15 minutes, then you pay for 15 minutes. By the way, Lambda functions can't run longer than 15 minutes at present. So you don't have to worry about that. So just know that serverless, also known as AWS Lambda, that's their version of serverless, is one of the simplest ways to run your code, but it's really designed for functions. So for a single task that can be done within 15 minutes. Now, can you string multiple AWS Lambda functions together? Absolutely. AWS has a service called step functions that will allow you to create application workflows that are all event-driven. In other words, do this, get the output from that, then do this, get the output from that, then do this. Step functions is designed for this. So you can actually orchestrate full applications with step functions and Lambda. So just keep that in mind. Don't sit there and think, oh my God, 15 minutes, that's it? That's ridiculous. Yeah, maybe. But for a single function, it's not ridiculous. For an entire application, that could be short. Okay, so that's serverless. So that's the highest abstraction level that you can use to run application code. Now, the middle tier, which is containers. Now, so containers, by the way, if you're not familiar with containers, let me just say this right now. Next to cloud, if there is one concept that everybody who can hear my voice right now needs to at least understand, if not master, it is the concept of Docker and containerization. because that is where everybody is headed, is to containerization. And I know people like make bombastic predictions like that all the time. This isn't a joke. 60 to 80% of most of the private sector deployments are moving into containers, and it's going to be the de facto way that we do deployments here in the next 5 years, if not sooner. So containerization is nothing more than process virtualization. So unlike before, where we were running multiple virtual machines on a per application basis, containers take the same process, but they jail it, they isolate it, and then that allows you to run multiple versions of the same process on the same operating system, but the processes can't see or really talk to each other unless you allow them to do so. So they're isolated from each other from a memory and process space. And so when you hear the word Docker, think of Docker as a brand of containerization. It's like Kleenex, that's just a brand of tissue. But Docker is just a form of containerization. But to be clear, Docker is by far the most popular form of containerization in the world. But when you hear the word Docker, you hear the word containers, they are taking processes like Java or .NET or C# or Ruby or whatever, and they are isolating them into their own jailed space. The reason this is cool is because then that you can take that container and you can run it anywhere that has the containerization software. So for example, if you need to scale from one host to thousands of hosts, so just so you know, a standard cluster in Kubernetes can run up to 5,000 hosts, so 5,000 virtual machines. This allows you to distribute containers across a large number of boxes, and you can actually use what's called container orchestration to manage how these processes are run all across your entire fleet of systems. Now, Amazon has 33 ways to run containers, but the two primary systems that matter the most when it comes to running containers are ECS and EKS. One is a proprietary Amazon-only product that's super simple to use and integrates really well with all of its services. And the other, the Elastic Kubernetes service, is an industry standard published by a consortium called the CNCF. And it is a upstream compliant distribution of Kubernetes, which allows you to be compliant with the standards around Kubernetes. So if you need community support, you need community extensibility, or you just love Kubernetes and just want to run it, managed Kubernetes from AWS is actually pretty good. Now, out of the big three hyperscale providers like Google and Azure and whatnot, you could argue that Google's better at it because they invented Kubernetes. But I got to tell you, EKS is a really solid service on AWS. So it's really good. Scalable, it's got a serverless option, great pricing, just amazing integrations, integrates well with IAM. There's a bunch of really cool features to this whole thing. But note that I said that Kubernetes has a complexity cost. So Kubernetes has a complexity curve that you have to eat, whereas the ECS service is a lot easier to use than Kubernetes is. So bottom line is that if you need industry compatibility, you should probably use EKS. If you just need to run a few containers and you just don't want to deal with EKS's headaches, you can just use ECS. Now, both of these run on top of virtual machines, which they call an EC2 launch type. And EC2 obviously is the virtual machine service. Both of them actually have a serverless version called Fargate. Now, why didn't they call it AWS like container serverless or just serverless? I don't even know. I think someone loved Farscape and someone loved Stargate, and they decided to mix them together. But just so you know, if you see the word Fargate, it's not a separate product. It's literally just the serverless version of these two services. So if you see Fargate, think serverless. Fargate, serverless. Fargate, serverless. That's all it is. So again, Amazon's marketing team needs to do some work, honestly. Cool thing about serverless, by the way, is that it's very much like Lambda, in that you only pay for the size of container you're running. You might say, well, hold on, Michael, what are you paying for otherwise? If you start an EKS cluster and you have it run with 5 T3 medium nodes, you're going to pay for those T3 medium nodes regardless of whether you're running a container or not. With Fargate, you only pay for the container itself. You don't pay for any worker nodes. So just know that you don't pay for any EC2 virtual machines if you are running Fargate. Okay. So again, remember, Lambda is serverless, so you don't get to see any servers. Then there's EC2, which runs virtual machines, which you obviously have to manage those completely. At this level here, you can run in what's called EC2 mode, or you can run in serverless mode. Both of them have their pros and cons, but just know that at the container level, the middle level, you have both serverless options and you have virtual machine options. So you're not constrained there. Okay. All right. A little knowledge check. 1, a customer wants to use an Amazon EC2 instance a la virtual machine for a batch processing workload, which means it's going to be CPU intensive. Which Amazon EC2 instance type should they use if they're going to do batch processing in that flavor? Good. Yeah, we're going to use compute optimized, right? Because it's CPU intensive. Notice that once again, they didn't stick accelerated computing as an answer. I don't, maybe they just don't like accelerated computing. All right, number 2. What are the 2 possible contract length options for Amazon EC2 reserved instances and compute savings plans? It's the same answer for both. Yeah, good. A and C. That's accurate. Good. So 1 and 3 years, just to make sure we're clear. All right, a customer has a workload that will run for a total of 6 months and can withstand interruptions. What's the most efficient EC2 instance purchasing option if they have an app that can withstand interruptions? Good. Yeah, spot instances. A customer wants to give users messages for the specific topics to which they have subscribed. What services uses topics and subscriptions? Good. Yeah, there's only one service that uses the concepts of topics and subscriptions. That would be the simple notification service. By the way, the simple notification service is not just email. It'll also do mobile push, SMS. It'll do web posts. It'll trigger Lambda functions. It'll trigger SQS. So don't think of this as, there is actually a simple email service. That email service is used for bulk email, sending. So this is not what the simple notification service is for. Simple notification service is specifically just for sending notifications en masse, which could include email. Okay. So we talked about serverless, we talked about containers, we talked about virtual machines. So the 3 levels of application hosting. We also talked about auto scaling and load balancing. So we covered those as well. And we talked about SNS and SQS, which are kind of sister services, which do a push and a pull model around message abstraction. So you can actually send messages, abstract messages away, right? You can buffer messages inside of a queue, which is what SQS does, right? Good. Any questions about billing, machine types, load balancing, any of those pieces? All right. It is 10:33. Let's do this. So let's take a 15-minute break. We'll just go ahead and extend it by 2 minutes. So we'll make it 17 minutes. So come back at 10 till, so 11:50. So come back at 11:50 and we will continue on with our next section, which is about networking. All right. Thanks for hanging out with me. We'll see you in a little bit. I'll put a timer up just like I did last time.